Last episode of Algebraic Expressions. Kindly subscribe to this channel because with this channel must become easier and very simple to solve. So if you're having any difficulty in any subject, just subscribe because more videos are going to be uploaded very soon, and you will see that math is simple and easier to understand. So let's go to the classroom to look at our final chapter of algebra, that is addition and fraction of algebraic expression. In our previous lessons, I gave some exercise to be tried, and the answers will be provided in our next lesson. So these are the answers with respect to our previous lessons. We are to look at additions and subtractions of algebraic expressions. And the additions and subtractions of algebraic expressions, we are to apply the rules and principles of fractions to aid us understand the additions and algebraic fractions. Now, the first rule says that anytime you have two fractions being separated by additions or subtractional symbol, we find LCM. So let's take a practical example of algebraic expression. Then we'll apply the rules or principles of fractions to solve it. The first one states that if you have 2 over x plus 1 over x plus 2, I'm to find the least common multiple of x plus 1 and x plus 2. The least common multiple for x plus 1 and x plus 2 is x plus 1 and x plus 2. So I'll bring my bar above and bring my least common multiple below. That's x plus 1 and x plus 2. X plus 1 divide x plus 1, that's x plus 2. So this x plus 2 will go and multiply these 2. That becomes 2 into bracket x plus 2 bracket close. Then this x plus 2 also divide x plus 2. Then this x plus 1 will go and multiply this 1. So I 1 into brackets x plus 2. Now the next step is to expand and bring our least common multiple below. So in the expanding, I have 2 times x will give me 2x. 2 times 2 will give me 4. 1 times x will give me x. Then 1 times 1 will give me 1. All divided by my least common multiple. And the next step is to group like terms. 2x and x are like terms. And 4 plus 1 are also like terms. So in grouping them, I have 2x plus x, then 4 plus 1, then my least common multiple will come below. So 2x plus x will give me 3x, then 4 plus 1 will give me 5, all divided by my least common multiple. So the final answer is given there. You have 3x plus 5 over x plus 1, then x plus 2. Let's take another practical example under algebraic fraction. I have a plus b all over 2 minus 2a all over 5. So this 2 and 5, I'll find my least common multiple of 2 and 5. The least common multiple of 2 and 5 is 10. So I'll bring my bar below and put my 10 there. Then 10 divided by 2. Note, we don't use 2 to divide 10. We use a 10 to divide the 2. So 10 divided by 2 will give me 5. Then 5 will expand the a plus b. So I have 5 into bracket a plus b. Then 10 divided by 5 will give me 2. These 2 will multiply the 2a. So I have minus 2a times 2. Then the next step is to bring my least common multiple below and expand the bracket. So 5 times a will give me 5a. 5 times b will give me 5b. Then minus 2a times 2 will give me minus 4a. You can see the answer provided below. My next step is to group like terms. 5a and 4a are like terms. This 5b is not having any like term. So 5 minus 4a will give me a plus 5 all divided by 10. And you can see the answer being provided over there. So 5 minus 4a will give me a plus b, which is unlike term to a, and divided by my least common multiple. The next practical example is going to be on 3m over m plus 4 plus 4 into bracket m plus 5. The least common multiple for m plus 4 and m plus 5 is m plus 4 and m plus 5. So I'll bring it blue with the bar under. So I have m plus 4 plus m plus 5. Now m plus 4 divide m plus 4, m plus 5. Then this m plus 5 will go and multiply 3m. So we have 3m to bracket m plus 5. Now this m plus 5 also come and divide m plus 5. I'm left with m plus 4. This m plus 4 will go and multiply this 4. So I have 4 to bracket m plus 4. My next step is to bring my least common multiple below, then expand the numbers on top. So 3 times m will give me 3m squared. Then 3 times 5 will give me 15m. That's 3m times 5 give me 15m. Then 4 times m will give me 4m. Then 4 times 4 will give me 16. So you can see the answers provided by 3 times m will give me 3m squared. 3m times 5 give me 15m. Then 4 times m will give me 4m. Then 4 times 4 will give me 16. Then the next step is to apply the same rules to continue. With the same rules, I have 3m squared plus 15m plus 4m plus 16, all divided by the least common multiple. Now, I'll group like terms. I have 15m plus 4m, that give me 19m. Then I have 3m squared here, it's having no like term, then I have my 16, divided by the least common multiple. Let's take the next example. That is 3 plus t all over 3, then minus 3 minus 2t all over 4. Here I'm to find the least common multiple of the 3 and m. That will give me 12. So 12 becomes my least common multiple. Then 12 divided by 3 is 4. This 4 will expand the 3 plus 4. Then 12 minus 4 give me 3. Note, I have negative sign here to affect the 3. So this negative 3 will expand the 3 minus 2t. So in expanding, 4 times 3 will give me 12. Then 4 times t will give me 40. Minus 3 times positive 3 will give me minus 9. Then negative 3 times negative 2 to give me positive 60. All divided by the least common multiple. Now the next step is to group like terms. These 12 and negative 9 are like terms. Then 2t and 60 are also like terms. So 12 minus negative 9, then 40 plus 60. So 12 minus 9 will give me positive 3, then 10t plus 60 will give me positive t, all divided by the least common multiple. Now, learners, I have some examples here for you to try it, and the answers will be provided in our subsequent lessons. Now, let's move on to another important topic under algebraic expressions, that is multiplications of two binomials. Under multiplications of two binomials, we are to apply the rules of distributive property and multiply each term with each binomial, and after that, like terms will be grouped. So let's take a practical example of how we can expand two binomials. So let's take the first one. I have a. This a will expand c plus d to become a into bracket c plus d. And this b also will come and expand the c plus d. So I have b into bracket c plus d. Before we can move further to practical examples, just know the following rules of algebra with the help of indices. I have a times a. A times a is ab. It's not a squared or b squared because the a and a are different bases, so I can't add the exponent. So I'll multiply a times b, that give me ab. Then the next stage, I have a times a. A and a have the same base, so I can add the exponent, exponent 1, that give me a to the power 2. Followed by 5a times 2b. Now I have a here, I have b here, they have unlike terms. So I multiply the 5 times 2. 5 times 2 give me 10. Then a times b will give me ab. Followed by 7a minus 5a. The a and a is making this two binomials to be having the same like terms. So I can subtract 7a and also 5a. So 5a minus 7a will give me 2a. Then followed by 7 times b. 7 times b, I have 7b. The next one is 10a plus 3a. The a and a have the same like terms, so I can add the 10 plus 3. That give me 13, so I have 13a. The next one is 5 times a squared. 5 times a squared will give us a, 5a squared. Then followed by 4 times ab plus ab. 4 times ab plus ab will give us 5ab. One may ask, why is it having 5 here? This ab has 1 attached to it, but the one there is hidden. So I have my 4 plus 1, that give me 5. So I'll pick one of their like terms, that's ab. That will give us 5ab. Then let's look at practical examples of how to expand using two binomials. First, I'll take a. A will expand a minus 5. And I'll take positive 2. We'll come and expand a minus 5. In expanding it, a times a, I have a squared. Then a times minus 5a, I have minus 5a. Then we have 2 times a, I have 2a. Then 2 times minus 5, I have negative 10. Looking at this, I can have like terms here. I have minus 5a and 2a to be like terms. So minus 5a plus 2a, that will give me negative 3a. Then this a squared and minus 10 are unlike terms. So I'll repeat the a squared and minus 10. It become my final answer for this practical example. Let's take the next practical example. I have x minus 5, then x plus 3. This x will expand x plus 3. Then this minus 5 will also expand x plus 3. So let's see how it goes. So my x will expand x plus 3. The minus 5 will expand x plus 3. So I have x times x will give me x squared. Then x times 3x will give me 3x. Then minus 5 times x will give me minus 5. Then minus 5 times 3 will give me minus 15. So you can see it below. Then you can see what I have like terms there. Yes, I have 3x and 5x to be like terms. So I have 3 minus 5x. That give me negative 2x. Then you have the x squared here and the negative 15 are unlike terms. So I'll repeat them below. So the final answer becomes x squared minus 2x minus 15. The next practical example, I have 3x minus 2. Then I have 2x plus 5. This 3x will expand 2x plus 5. Then this minus 2 will expand 2x plus 5. So let's continue to look at how we can expand. So my 3x will expand 2x plus 5 minus 2 into bracket 2x plus 5. 3x times 2 will give me 6x. Then 3x times 5 give me 15x. Minus 2 times 2x will give me minus 4x. Then minus 2 times positive 5 will give me minus 10. So I have positive 6x squared plus 15x minus 4x minus 10. Now 15x minus 4x are like terms, so I can subtract 15 and 4x. So 15 from minus 4x from 15x will give me 11x. So I'll repeat my 6x squared minus 10. So the 6x squared and 10x squared and the 11x are unlike terms, so become my final answer. Now I have some perfect squares here for us also to continue with our lessons. Perfect squares are very important in algebraic expressions. And the perfect squares, we are to look at two perfect numbers that are having a subtractional sign between them with a perfect number. So let's take the first example. I have a squared minus b squared. This a squared and b squared, it is being called difference of two squares or perfect squares. So this difference of two squares, you have a square separating two perfect square numbers. And before we can expand, you have a negative and a positive separating the expansion. So I have the first one, a plus b followed by a minus b. So taking a practical examples of the perfect squares or difference of two squares, I have x squared minus 36. Now this 36 is a perfect square. The subtraction sign is making it to be having a term called difference of two squares. So 36 becomes 6 times 6, that will give me 36. And I have x squared, so it becomes x squared minus 6 to the power 2. So we can see from my example, we have x squared minus 6 to the power 2. Anytime you have a perfect square having a negative sign beside it, the next stage is to have the x adding the number without the square on top, followed by the x subtracting the number without the square on top. So let's look at practical example. I have the x adding the number without the square on top, and I have the x subtracting the number without the square on top. So I have x plus 6 and x minus 6. When we expand this, we'll get back to this answer again. So learners, you can try to expand this with the knowledge from the previous exercises we have solved and see what I'm going to get to x squared minus 36. Let's take another practical example. I have 9y squared minus 100. This 9 here is a perfect squared, 100 here is a perfect squared, because 9 will give us 3 times 3 will give us 9. 100 is 10 times 10. So moving forward, the 9 here will give us 3 to the power 2, because 3 times 3 will give us 9. And I will maintain my y squared minus 10 to the power 2, because 10 times 10 will give me 100. So to move further, I will pick this 3 without the square on top, and also the y without the square on top, and I'll pick my 10 without the square on top to have 3y plus 10 bracket close, then into bracket again 3y minus 10. So we have 3y plus 10, then 3y minus 10. Now when you expand this with the knowledge from the previous example, we will get back to the 9y squared minus 100. Let's take another example. I have 36x squared minus 121. 36 here and 121 are perfect squares. Separated by a negative, so become difference of two squares. 36 becomes 6 to the power 2, and 121 becomes 11 to the power 2. So I have 6 to the power 2 with the x attached to it, and 11 to the power 2. I will pick the 6 and add it to the 11, so it becomes 6 into brackets plus 11. But note, the 6 adds square to it, so it becomes 6x plus 11, then into brackets 6x minus 11. So we have 6x plus 11, then 6x minus 11. Note, I can interchange them. I can bring the 6x minus 11 here, then 6x plus 11 here. When I expand, I'll get back to the 36x squared minus 121. Let's take the next example. 49b squared minus 169a squared. 49 is a perfect squared. 169 is a perfect squared. Being separated by a negative sign, it becomes difference of two perfect squares. So now the 49 becomes 7 is 49. That is 7 times 7 is 49. 169 becomes 13 times 13 will give me 169. So I will pick my first 7 squared, then multiply b squared minus 13 squared multiplying the a squared. So we have 7 squared multiplying b squared minus 13 squared multiplying the a squared. Then I said earlier, this 7 will add the 13, but no, the 7 has b attached to it, becomes 7b plus 13, then 7b minus 13. So you can interchange the 7b minus 13 here and bring the 7b plus 13 here. When we expand this, we can come back to the same answer. That is 49b squared minus 169a squared. Now, I have some examples here for you to try it. The answers will be provided in our subsequent lesson. Then, we are to look at squaring of binomials. How to square two binomials. Another important subtopic under algebra. In squaring two binomials, here is different from difference of two squares. Now here, always you have a letter or a variable with an additional sign with a letter or variable, all into bracket squared. Then the next stage is to add, so become a plus b plus a plus b. With the square root of two binomials, when expanding, the sign here will affect both two expansions. So we have a plus b and a plus b. So the sign here possibly will affect the a plus b and affect the a plus b here too. So we have a plus b, then a plus b. The next one also, we are to expand. So this a will expand the a plus b, and positive b will also expand the a plus b. So a times a will give me a squared, then a times b will give me ab. Then b times a will give me ba or ab, then b times b will give me b squared. You can see it below there. The next stage is to group like terms. A squared plus ab plus ab plus b squared. This ab and ab are like terms, so I can add. Now, one is attached to the ab by its heading. Another one is here, it's also heading. So 1 plus 1 will give me 2. So it becomes 2ab. And the a squared and b squared are unlike terms. So I'll just repeat them below. So I have a squared plus 2ab plus b squared. Now let's take a practical example of how binomials are being squared. Now I have a plus 4 onto bracket squared. Now the positive here will affect both expansion. So I have a plus 4 and a plus 4. In further expansion, I will have my a multiply my a plus 4, then positive 4 will multiply my a plus 4. So a times a will give me a squared, then a times 4 will give me 4a. Then 4 times a will give me 4a, then 4 times 4 will give me 16. Then in grouping like terms, this 4a and 4a are like terms. So 4 plus 4 give me 8, and the a squared and the 16 are unlike terms. So I'll repeat them below. So a squared plus a plus 8a plus 16 becomes my final answer. Now let's move on to the next example that has a negative sign between the two binomials. So we have x minus 2y. You can see negative sign separating it. And I said earlier, anytime you have a bracket sign, two bracket sign with a squared on top, the negative here will affect both expansion. So here I have negative here to affect this negative here and affect the negative here. So in expanding, I have x minus 2y and x minus 2y. Then let's expand. I will pick this x to expand x minus 2y. The negative 2y also expand x minus 2y. So in expanding, x times s will give us x squared. Then x minus 2 will give us minus 2xy. The minus y times s will give us minus xy. The minus 2 times negative 2y. So negative 2y times negative will give us positive 4y squared. So the answer we provided below. You have x squared minus 2xy minus 2xy plus 4y squared. Here, minus 2xy and minus 2xy are like terms, so I can subtract. By x squared and 4y squared are unlike terms, so I'll repeat them below. So minus 2xy minus 2xy give us minus 4xy. So minus 2xy minus 2xy give us minus 4xy. Now repeat my x squared plus 4y squared. Now, learners, I will have some trial work to be tried and answers will be provided in our subsequent lesson. Have a date with us for our subsequent lesson that will be based on fractions. We are going to treat fractions to details. So have a date with us and share this link, subscribe to this link to your senior brothers and sisters from different schools, aunties from different schools, uncles from different schools. Share to their children to learn, and we'll see an impact in them in mathematics. Once we move on, thank you for watching.